Hello my dear students. So welcome to my channel Dey Sir's Chemistry Coaching. Thank you for supporting me. I believe without your cooperation I can't proceed. So please keep watching my channel. I will try my best to reach to you. Okay, so let's start the another topics, and remember it. These are very helpful for your forthcoming board exam as well as entrance exams such as JEE mains and neet. So please do remain with me. Thank you. So today's topic, nucleophilic addition reaction part 2. In my previous lectures I have told you that presence of electron donating groups decreases the reactivity towards nucleophilic addition reaction, while presence of electron withdrawing group increases the reactivity towards nucleophilic addition reactions. Now some explanations or explain why, which are very helpful for your board and entrance. Okay, and after that I will start examples of nucleophilic addition reactions. Okay, so please do watching. Why nucleophilic addition reaction takes place in acidic medium? As nucleophile approaches to carbonyl group, the pi bond moves towards the more electronegative oxygen atom. That's why polarization takes place. The carbonyl group becomes polar, carbon becomes positively charged, oxygen becomes negatively charged, and the nucleophile easily gets attached to the carbonyl carbon. So the main thing is development of charge on carbonyl group. This is the main conception on nucleophilic addition reactions. The extent of nucleophilic addition reaction depends on the development of positive charge on the carbonyl carbon. So greater the positive charge on carbonyl carbon, more will be the reactivity. Now, in acidic medium, it's a weakly acidic medium, okay? Remember it, not strongly. Why? In the next question I will discuss. In acidic medium, what happens? In acidic medium, the polarity of CO group increases. Polarity means development of positive and negative charge increases. As the oxygen has lone pair of electron, so the proton gets attached to the oxygen atom. So oxygen becomes positively charged, and remember it, in organic chemistry, any positively charged ion where it gets attached, the central part becomes positive charge. In organic chemistry, any positive charge ion where it gets attached, the central part becomes positive charge. As oxygen is more electronegative than carbon, so oxygen cannot have positively charged. I repeat, as oxygen is more electronegative, the electronegativity value of oxygen is 3.5, then carbon 2.4, so oxygen cannot have positively charged. When the nucleophile approaches towards the carbonyl group, see what will happen. This is nucleophile. You already know that nucleophiles are any negatively charged ions such as cyanide ion, Cn negative, halide ions, any negatively charged ions, as well as neutral molecules having lone pair of electrons. Neutral molecules having lone pair of electrons such as ammonia, derivative of ammonia, water, etc. Continuation, okay? Continuation. I will write here. Continuation. Thus you see, nucleophilic addition reaction easily takes place in weakly acidic medium. In weakly acidic medium. Clear? Now the next question. cyclohexanone easily undergoes nucleophilic addition reaction while 2,6-dimethyl cyclohexanone does not. Actually, it should be 2,6-dimethyl cyclohexanone does not. Why? What is the reason? Okay. Now, listen. Before writing the answer of any explain why, at first draw the structure of concerned compounds. Cyclohexanone. Methyl, ethyl, propyl, butyl, pentyl, hexyl, hexanone. Ketone means one. Insert 2 methyl group at 2 and 6 positions. To 6-dimethyl cyclohexanone. Can you tell me the answer? Anyone? So, these 2 methyl groups are very close to the carbon atom. That's why due to the bulky nature of 2 methyl groups, steric hindrance occurs. So the nucleophile cannot easily approaches towards the carbon atom. That's why it is less reactive. After drawing it, okay? Due to the presence of 2 methyl groups at 2 and 6 positions of 2,6-dimethyl cyclohexanone, the incoming nucleophile cannot attach to the carbonyl carbon. It is steric hindrance. That's why 2,6-dimethyl cyclohexanone is less reactive than cyclohexanone. Okay. So write it, okay? It is due to steric hindrance. Please, whenever you watch my videos, do practice with me. All the classes are classroom format coaching, okay? There are two types of nucleophilic addition reactions. One, without elimination of any byproduct, and the second type, elimination of smaller molecules, mainly water here, okay? So let's proceed. Examples of nucleophilic addition reaction without elimination of any byproduct. With hydrocyanic acid. Remember it, hydrocyanic acid, here it is reagent. During any chemical reaction, reagents are taken in a small extent and the main compound called reactant, which are to be taken a little bit larger extent. Whenever you dissociate hydrocyanic acid, the hydrogen positive ion gets attached to the carbonyl carbon. The hydrogen positive ion gets attached to the oxygen atom, and the negative charge cyano group attached to the carbonyl carbon. Why? Due to the polarization development of positive and negative charge on carbonyl group, you know that oppositely charged ions in a solution are attached to each other. So acetaldehyde cyanohydrin is formed. This is an addition product. This is the question, okay? If the question will come, what will happen when acetaldehyde reacts with hydrocyanic acid? Up to this, write it. But if the question will come, what will happen when acetaldehyde reacts with hydrocyanic acid followed by acid hydrolysis? I repeat, followed by acid hydrolysis. Then only write do you know what are acid hydrolysis? Just boiled with dilute mineral acids such as hydrochloric acid. Dilute means water. Any acid furnishes hydrogen positive ion. That's why acid hydrolysis is symbolized by this way. You have seen that it may be written in another way also. Just attach them, you get it. So this is the very important point. Please note down. It is important for entrance too. In organic chemistry, any compound, whether it is aliphatic or aromatic, if it contains cyano group, on acid hydrolysis, just change the cyano group into corresponding carboxylic acid. So once again I repeat, in organic chemistry, if any compound, aliphatic or aromatic, contains cyano group, if you undergo acid hydrolysis, then remember it, don't change any other group, rather change only the cyano group into carboxylic acid group. This is very helpful for your entrance also, okay? I'll write here, okay, the product. This is called lactic acid. Write it, okay? So the next, reaction of hydrocyanic acid with acetone. How to draw the structure of acetone? Very easy. See, this is acetaldehyde. If you replace this hydrogen by CH3 group, it becomes acetone. This is the addition product. So you get acetone cyanohydrine, okay? I think you understand it. So next question is very important for entrance also, okay? Please try to understand it. Don't write, only understand. Don't write it. Just understand it. I will write the question and answer too. This is lactic acid. Only understand. Don't write. I will write the question with answer. Important for entrance and board. If we consider this carbon atom, the central carbon atom, it contains 4 different atoms or groups. If any carbon contains 4 different atoms or groups, that is called chiral or asymmetric carbon atom. Actually, lactic acid is optically active because it rotates the plane polarized light. Later on, whenever I will discuss isomerism, that is stereoisomerism, in my entrance classes, I will clear you optical activity, optical isomerism, etc. Okay. So lactic acid is optically active. Because it rotates the plane polarized light. It forms non-superimposable mirror image. It has chiral or asymmetric carbon atoms. But, understand it, but the lactic acid which we get during the reaction of acetaldehyde and hydrocyanic acid on acid hydrolysis is optically inactive. If we consider only lactic acid, it is optically active. But if we consider the lactic acid, I repeat, the lactic acid which is formed during the reaction of acetaldehyde and acetone followed by acid hydrolysis is optically inactive. Why? Write the question. Write down. The lactic acid forms by the reaction of acetaldehyde and hydrocyanic acid is optically inactive. Why? But remember it, if we consider only structure of lactic acid, it's optically active. But this lactic acid is optically very interesting. Because the lactic acid which we get by this reaction is a racemic mixture. Do you know what is racemic mixture? If any mixture or any solution contains 50% dextrorotatory compound and 50% levorotatory compound, then they are called racemic mixture. The mixture contains 50% dextro and 50% levo. These are the part of optical isomerism. In another class, I will clear optical isomerism, okay? This much is sufficient, okay, because the question carries hardly 1 mark. Just little bit try to understand dextro and levorotatory, okay. Listen now. This is a glass beaker. You have taken lactic acid. We can prepare in laboratory separately dextrorotatory and levorotatory lactic acid, that we can prepare separately because they can be separated. Imagine it, this is a dextrorotatory lactic acid, it's a glass beaker. This is an instrument called polarimeter. Later on I will discuss in another classes, okay, isomerism. You see through the polarimeter the liquid. You can't understand anything, okay. Now imagine it. Just pass plain polarized light, okay. Just pass plain polarized light, special type of light, plain polarized light into the solution. Just pass plain polarized light into the light, goes straight away into the solution, and see through polarimeter. You see the plain polarized light. Actually light has certain dipole. Say this is the dipole of plain polarized light. If the plain polarized light rotates towards right direction, your right direction, towards right direction, the compound is said to be dextrorotatory, and if we see through a polarimeter that the dipole of plane polarized light just this way rotates to the left direction, your left direction, that is called laboratory, and then we conclude that the solution is optically active. But this lactic acid which we get by the reaction of acetaldehyde and hydrocyanic acid is optically inactive, because this mixture, if you consider this mixture contains 50% molecules of dextrorotatory and 50% molecules of laboratory, so one compensates other, and that's why the total solution becomes optically inactive. Means the lactic acid which you get by this reaction, if you pass plane polarized light and see through the polarimeter, this is the polarimeter, it's an instrument to measure the optical activity. I repeat, polarimeter is an instrument or device to measure the optical activity. This is the polarimeter holding here, pass plane polarized light. You know that plane polarized light has certain dipole. Whenever you see through polarimeter, you see that there is no movement of plane polarized light. The dipole is no movement, nothing movement, neither right direction or left direction. Then you conclude that this solution is optically inactive. Very interesting question, okay? So, next. Nucleophilic addition reaction examples are going on where there is no elimination of byproduct. In my first reaction, I have given the reaction with hydrocyanic acid. This is the reagent. It reacts with acetaldehyde and acetone separately. Another type of reagent is there, that is called sodium bisulfite or sodium hydrogen sulfide. This is the reagent. It once reacts with acetaldehyde and with acetone. Okay, understand? This is called sodium hydrogen sulfite Te or sodium bisulfite. This is reagent. It once reacts with acetaldehyde and once with acetone. Hydrogen gets positively charged and the sulfur gets negative charge. So whenever you write the charge, write on the particular element, okay? You know that in a solution, oppositely charged ions are attached hydrogen positive gets attached to oxygen negative, and the sulfur negatively charged attached to the carbonyl carbon which gets positive charge. This is an addition product. It is formed from acetaldehyde and sodium bisulfite, so its name also I think you understand it. Whenever you study chemistry, just clear the conception. Okay? How to draw the structure of acetone? Very easy, just follow the tricks. Replace this hydrogen by methyl group, CH3 group. So it becomes acetone. So you get product acetone sodium bisulfite. Write it, okay? I will read it, okay? Write down one very important note for your entrance exam. So remember it. Do you know what are identification tests? Listen. During any reaction, if precipitate is formed, if product has characteristic smell. If there will be a change of color, reactant to product, there are different colors. You see, that's called identification test. In another classes, very shortly I will discuss identification test, okay? So, examples of nucleophilic addition reactions are going on. Already I have covered nucleophilic addition reactions without elimination of any byproduct. The first example I have given with hydrocyanic acid, and the second example I have given with sodium bisulfite. They are called reagents and they react once with acetaldehyde and with acetone, okay? The reaction of aldehydes and ketones with sodium bisulfite is an identification test of carbonyl compounds. You know that aldehydes and ketones together are called carbonyl compounds. So the next type of nucleophilic addition reactions, these are with ammonia derivatives, where you get one byproduct, mainly here it is water. One thing is, remember, the reaction of ammonia derivative, I will start, with aldehydes and ketones takes place in weakly acidic medium. I repeat, in weakly acidic medium only. But if strongly acidic medium is used, no reaction takes place. That's the very important for your forthcoming NEET or JEE mains. Okay. Question. Right, it okay? It's very important board as well as entrance question. The reactions of ammonia derivatives with carbonyl compounds such as aldehydes and ketones occur in weakly acidic medium, not in strongly acidic medium. Why? Let's understand the mechanism of reaction. Do you know what are ammonia derivatives? If one hydrogen atom of ammonia is replaced by some groups, then the resulting compounds are called ammonia derivatives. At first, understand the answer of the question, then I will start the reactions of aldehydes and ketones with ammonia derivatives. Please stay with me. There are lots of conception. Hydrogen positive ion from weakly acid gets attached to the oxygen atom. As oxygen has lone pair of electrons, when a nucleophile coming from the reagents, these are also called attacking site, approaches towards the aldehydes or ketones. As oxygen is more electronegative than carbon, so oxygen cannot have positively charged. That's why oxygen attracts one pi bond. You know that a double bond contains one sigma and one pi. Sigma bond is stable, pi bond is weak. So pi bond starts to break. As soon as the oxygen, positively charged oxygen atom attracts the pi bond, so carbon becomes positively charged, because you know that removal of electron from any element makes it positive charge. As the carbon becomes positive charge, I have not mentioned here, just imagine. So the nucleophile gets attached to the carbonyl carbon. You get addition product. The oxygen as becomes positively charged. As you know that due to very high electronegativity of oxygen atom, it cannot be positive charge. That's why by gaining the pi electron from the carbon atoms, it becomes neutral. I have not mentioned any charge. This is the main mechanism of nucleophilic addition reaction of aldehydes and ketones in weakly acidic medium. But if the reaction takes place in strongly acidic medium, what happens? Continuation and answer, okay? Write it. Now, listen. When nucleophilic addition reaction takes place between ammonia derivatives with aldehydes or ketones, the reaction should occur in weakly acidic medium because the keto group C double bonded O becomes polar nature very fast. But if the reaction of carbonyl compounds, that is aldehydes and ketones, with ammonia derivatives takes place in strongly acidic medium, strongly acidic medium, say sulfuric acid, strong acid, then the hydrogen positive ion furnishes from the strong acid gets attached to the ammonia derivatives as they are very weak base and the nitrogen atom contains lone pair of electrons. Instead of attacking the oxygen atom of carbonyl group. That's why the nucleophile cannot act as a nucleophile as it gets positive charge, that is anilinium ion. See how. The hydrogen positive ion from the strong acid gets attached to the lone pair of nitrogen of ammonia derivatives as they are weak electrophiles. So we get anilinium ion, that is the nitrogen becomes positive charge. Thus it cannot act as a nucleophile because you know that nucleophiles are those species which contains negative charge or neutral molecules having lone pair of electrons, but it has positive charge, so it cannot act as nucleophile, so the reaction does not occur. This is the explanation for this question. Okay, very important conception for board as well as entrance. You see, in my every class, I will mix the topics with your board as well as entrance. Okay, so please keep watching my videos, teaching methodology. If you have anything to ask, please do write at my comment box. Okay, so this much for today's class. Thank you.